Bienvenidos, Ushamdi, and welcome CTS230, Section 841 students for the first 8-week term of the fall 2017 semester at Anne Arundel Community College. This is the Networking 3 or the Scaling Networks V6 course from Cisco Networking Academy. And this afternoon's video tutorial is going to be a solution set and tutorial on Packet Tracer Activity 10.3.1.2. In fact, this is the final packet tracer activity of the first 8-week term, and this is your OSPF Skills Integration Challenge. So let's dive in here and take a look at what we're going to be asked to do. Now, very straightforward setup here, right? Not too difficult, a short list of instructions, and we can see we've got the always or ever present web server out here at 64100.1.2. We've got a very short addressing table, very straightforward. All of the routers are in the /24 192.168.1.0 network. And we've got router A is, which I'm sure I'm going to call router 1 numerous times, is 192.168.1.1. 1.2 for router B, and 1.3 for router C. And we've got this multi-access segment here, and without even looking at the instructions, rest assured that we're probably going to be doing some DR, BDR work. All right. So let's go ahead and dive in here. Use the following requirements to configure OSPFv2 on router A and router B. And we'll start with router A. So let's give ourselves, a little more real estate with which to work here. And let's get to that CLI. And we are starting on router A. So let's go from user exec to privilege exec and into global config with the conf t command. And the routing requirements, right? The process ID needs to be 1. So router OSPF1. Network address for each interface. Well, do show IP interface brief. Do we have any loopbacks? We do not. It looks like we have that single interface there, just the gig 00. So let's go ahead and say network 192.168.1.0, 0.0.0.255 for our wildcard mask. And all area or all interfaces are going to be in area 0. Now this is interesting here. They talk about enabling authentication in area 0. So this is our first look at authentication. So if I was to say area 0, authentication message digest, that is going to turn authentication on in area 0. And we're going to be using MD5. Right, so enable authentication for area 0. Now, we've got some other commands that we're going to have to use because they're giving us the, further down here, the MD5 authentication key that we're going to be using. So we're going to have to apply that as well. But before we get there, let's go ahead. It says OSPF Priority Set to 150 on the LAN interface of router A. So let's get into interface gig 00, and we're going to say IP OSPF Priority. And so this is going to be the DR, and 150 was the priority value. All right, and it wants authentication on the LAN interfaces of router A and B. So the hello interval, IP OSPF hello interval, is going to be 5, and it's packet tracer, so we're not going to be counting on the fact. Let me see, in fact, do show IP OSPF interfaces. Yeah, so this is interesting. So packet tracer does not make the connection between the hello interval being changed and the fact that the dead interval would be changed to 4 times that auto-magically. Again, and this is important, right? So let's take a look at this one more time on, on the command line here of a real Cisco router. In fact, let's go to a router that I know is running, and I want to say 15. I think this is running 5.7 or 15.7 code. Yeah. So this is the latest and greatest 15.7 branch of code here. So let's get into global config, and let's say router OSPF1 interface gig 00. And if I say IP OSPF hello interval 5, and then I say do show IP OSPF interfaces, and do show run interface gig 00. And I apologize, IP OSPF1 area 0. I assume we had a network statement and we don't. So now let's rerun that IP-OSPF interfaces, and does it make the connection? Yeah, so real iOS is going to make that connection, that you've changed the hello interval, and so the dead interval is simply 4 times that because that's the default. But with packet tracer, right, we need to be careful here because it's going to leave it as the dead time of 40. So we have to come in and say IPOS, or the dead interval. We need to force it to 20. And again, if you're using something that's not 4 times with real iOS, so real Cisco iOS, let's say you wanted it to behave like EIGRP, 5 and 15. So when you set it to 5, iOS with OSPF is going to say, oh, the dead interval is 20. So it's a good time to go ahead and go in and put the command in, because this is also what we saw is when we went in here and I said IP-OSPF dead interval and I put in 20, right? When we say do show run interface gig 00, interesting, 15.7 code puts it in here. Remember we did this just the other day, I think it was routers 8 and 9, where it show run interface serial 000, yeah, where it didn't put it in there, it left, and this is 15.1 code. So again, make sure you check to see how the version of iOS that you're running is going to behave. Okay, so we're set here. Now we're already under the interface. So how would we handle authentication? Well, I was going to try to show us a little activity here. Let's say IP-OSPF. And if I do a question mark, you can see it's authentication, right? It says enable authentication. Well, we've already enabled authentication under the global process, because remember, there's 2 ways you can enable authentication for OSPF. You can have both commands run under the interface, or you can have one command run that's going to be area-wide under the OSPF router config section, which is what we did, and then put a command, option under the interface. And so that's what we're going to do. So we're going to say IP-OSPF message digest key 1 MD5. And what is the password going to be? Well, we're going to use Cisco. So we'll say CISCO. Now it's interesting, they're not asking us to do anything on router C just yet. This is just routers A and B. All right, so that takes care of router A, and we're at 29 out of 100 points, so we're good there. So let's say end, let's save our config here, and now let's transition over to router B, where we're going to do much the same thing here. We'll go to the CLI. We'll come down to router B. We'll go from user exec to privilege exec into global config. And we're simply going to say router OSPF 1. And I'm rereading here real quickly. Do show IP interface brief. All right, so single network statement 192.168.1.0, 0.0.0.255. And we are going to be in area 0. Now let's get into that interface gigabit Ethernet 00. I'm going to set my IP OSPF priority to 100, ensuring that router B will be elected as the BDR, or the backup designated router. Now you're probably wondering, wait a second, and actually I jumped onto the interface too quickly. Wait a second, there's no adjacency. Why do we not have the adjacency forming here? If I say do show IP OSPF neighbor, there's no adjacency. And the reason is if I say do debug IP OSPF adjacency, let's see what kind of events we might be presented with. In fact, let's kick that off on router A. So debug IP OSPF, and it's going to be adjacency, and let's look at events over here as well. And let's see if we see anything. Yeah, fantastic, right? So mismatched authentication type. The input packet specified type 0. And there's 3 types. There's type 0, which is no authentication. And again, interesting that there's a type for no authentication, but it's type 0. So type 0 means you have no authentication set up. Type 1 means that we're using plain text authentication. And type 2 means that we're using MD5, right? So take a look. Input packet specified, this is router A, and it says the input packet, the packet that we're receiving, is saying that we have type 0 for authentication. we use type 2. And so this is another parameter, right? Remember, the hello interval needs to match. The MTU, the subnet mask, the area number, the authentication needs to match. So lots of things that need to match with OSPF, right? And the chart in the text is excellent, and definitely commit that to memory before you sit for your CCNA. So we can clearly see here that we've got an authentication mismatch. So let's sort that out, and this was the comment I made over here earlier. Let's go first under router OSPF1, and I'm going to say area 0, authentication, message digest, and then I would go under the interface gig00, where I would say IP OSPF, message digest key 1, MD5, and then Cisco. Now, this is going to resolve that debug message, and we should see, and actually, why not? So again, fortuitous failure, because there's still some things we need to do. Why is the adjacency not forming? And we can see it in the debugs up here. R meaning received, C meaning configured. So on router 1, the hello interval, or I'm sorry, the dead interval is 20, but we're receiving a hello packet that has 40. And same thing here. We're receiving in the hello interval, we're receiving 10, the default, but we're configured for 5. So not going to form. So IP OSPF, hello interval is going to be 5, and the dead interval we will set to 20. And now we should see, and there we go. And now we have, and take a look. This is great. I love this. We're going to let me kill that debug, and let me go back. We're going to say you all, right? Really, really enjoy the verbose, rich output that we get from the debugs, especially when that output shows us something that we've talked about. So take a look. It was right here, end hello processing neighbor change event. Who is elected first? The BDR is elected first, right? And the quad zeros is that there was nobody, and then we promote ourselves because we have a higher priority, but the BDR is elected before the DR. And then you can see here, the DR then gets elected, and then we go on and we fill in with, and we should see, hopefully I didn't kill it too soon. Yeah, we didn't see the BDR, but the BDR will end up being, and there we go. Okay, good. And the BDR becomes router B. So the DR is router A, and the BDR is router B. So if I say show IP OSPF neighbors, we should see that, right? So there's the router ID of router 2. The priority that router 2 is advertising or flooding in its hello packets. We're fully adjacent because we're on a multi-access segment. And the state of router 2 is it is the BDR. It is the backup designated router. That's how, excuse me, that's our dead time. Remember, we changed it from 40, the default, to 20. Here's the IP address that we would reach router 2 on, and there's the interface out which we would go to get to router 2. So we've taken care of everything with router 2, including the authentication. And that threw me. I was not anticipating we were going to have authentication as part of this activity. Okay, so now we're going to do router C, and it looks like there's going to be some heavy lifting here on router C. It seems like there's more things going on. So let's come up here, and we'll bring router C up to the top. All right, so for router C, and actually there are more things to do, router C is what would be considered the ASBR, right? This is our autonomous system boundary router because it's not between areas. If it was between OSPF, if this was an OSPF area over here, it would be an ABR, an area border router. But this is our OSPF area 0. This is our backbone area. And this is foreign information over here. This is information outside of the OSPF domain. And so C is the autonomous system boundary router because it's got connectivity and it's got information that is from outside the OSPF domain. And it's also the only exit point for us to get out of the OSPF domain, or this local segment, the 192.168.1, out to the internet. So let's bring up router C, and here we go. We are going to go from user exec to privilege exec into global config, router OSPF1, and what are we doing here? Network address for the LAN interface. So do show IP interface brief. Let's see what interfaces we've got. So we're going to have a network statement in here for the 192.168.1.0.0.0.255 area, and the area is still going to be 0. Set all interfaces to passive by default. Very easy to do, right? But we need to make sure allow OSPF updates on the active LAN. No passive interface gig 00, because that is where this is gig 00, right? And it makes sense because we have to have the adjacencies form here to share that OSPF information in what I believe is probably going to be a default information originate. Okay, set the router to distribute default route, so default information originate. Configure a directly attached default route to the internet. It doesn't tell us whether we should use the interface or not. We will use the interface. Serial 000. So IP route quad zeros and out serial 000. All right. So the OSPF priority on the LAN interface, which is going to be gig 00, we're going to set that OSPF priority to 50. And OSPF MD authentication key. Well, let's get back into router OSPF1. Did I miss that up top? Yeah, enable authentication. I apologize. So area 0 authentication is message digest. We get back under the interface for gig 00. IP OSPF message digest key 1, MD5, and it is Cisco. So adjacency, is it going to form? No. Remember, we still have 2 parameters that we need to tweak here, and that's going to be IP OSPF hello interval of 5 and a dead interval of, and what did we want, 15 here? No, 20, sorry. And a dead interval of 20. And so we are now sitting, that's it. We've got 100 points, right? But we've got some other things to do. It says, issue the clear IP OSPF proc on router C if the default route does not propagate. Well, let's check. Did the default route propagate? We're on router A here. And again, the neighbor, right? Remember, that's the router ID of router C. That is not the, when it says neighbor, this is not the address on router 1 that we are adjacent with. That is the router ID of router C. And so do we have connectivity first? Ping 64.100.1.2. Can we get to the internet? We can, which means show IP route. There is our OE2 external type 2 route that takes us out to the internet, right? And again, behind the scenes, that default information originate command is really just redistributing from a foreign routing protocol, which in the case of router C is the static protocol, and it's redistributing that information into the OSPF domain, which is why we see it as an OE2, right? All right, well, this wraps up packet tracer activity 10.3.1.2, the OSPF Skills Integration Challenge. And this wraps up all of the packet tracer activities for the first 8-week term of the fall 2017 semester in Networking 3. Enjoy the rest of your weekend, study hard, and I will see you Tuesday night for the final. Have a great weekend.